NASA has identified a mysterious object in the solar system that poses a huge puzzle even for the most experienced astronomers. Since Oumuamua entered our home world a few years ago, the wildest theories have been circulating about its true origins. But now, two researchers believe they have finally uncovered the secrets of this interstellar visitor. So, are we dealing with a purely natural celestial body, or is the renowned Harvard professor right in speculating that the object is an extraterrestrial spacecraft? Stay tuned until the end and find out with us. What began as a celebrated, sensational discovery quickly developed into one of the greatest space mysteries of our time. But what happened? Well, to understand this, we should first remember that in the cosmos, literally no stone is left unturned, and that millions of asteroids, comets, and meteoroids regularly become the focus of astronomical interest. And yet, what was detected by the Pan-STARRS telescope in Hawaii on October 19, 2017 was clearly different from anything known before. The origin of this object was not in our solar system. And so it came to pass that the celestial body christened Oumuamua became the first known interstellar visitor ever. However, experts would only realize a little later that this strange surprise guest had a number of other mysteries in store. Initially, the not particularly spectacular assumption was made that we were simply dealing with an ordinary comet. The crucial catch, however, was that Oumuamua's mysterious properties and unusual flight behavior simply could not be classified according to any known pattern. The basic rule is that if the object had been a comet, it would have had a characteristic tail and a so-called coma. This is the diffuse fog-like envelope of gas and dust that surrounds the core of a comet as it approaches the Sun. However, a more detailed analysis failed to reveal any of these typical features. Even more confusing was the trajectory that the object followed on its journey. The bottom line was that at the time of its discovery, Oumuamua was already on its way back into interstellar space. It had passed our blue home planet 5 days earlier at a distance of 24 million kilometers. A few weeks earlier, on September 2, 2017, the object had entered the solar system almost perpendicular to the orbital planes of the planets. Reconstructing this path revealed that Oumuamua's roots must lie somewhere in the constellation Lyra. 7 days after its arrival in our home system, the object came into close contact with the Sun. It approached our host star to within 37.6 million kilometers and then performed a U-turn that took it back into the vast expanses of space. However, data analysis from various telescopes, including the Hubble Space Telescope, revealed a surprising detail that immediately left researchers feeling both astonished and perplexed. Apparently, Oumuamua had accelerated during its flight around the Sun. Astronomical guesswork. The confusing deviation from its trajectory in which the object flew slightly faster than the influence of gravity alone would have allowed soon fueled the most adventurous speculation. Initially, however, experts attempted to solve the mystery using not so unconventional means such as the so-called outgassing of volatile components. In other words, the Sun heated up the flying object so much that various gases and dust were blown into space, giving it an extra boost of speed. But even this assumption was accompanied by two crucial question marks. On the one hand, not a single speck of dust could be detected in the immediate vicinity of the object. And on the other, outgassing is always accompanied by a drastic change in rotational behavior. And as you can probably imagine, there was no trace of such a change in the case of Oumuamua. But speaking of rotational behavior, the interstellar visitor also broke every known pattern in this regard. Instead of rotating around one of its main axes, the object is literally tumbling through space. Scientists came to this conclusion when they analyzed the equally puzzling fluctuations in the celestial body's brightness. Its brightness is subject to periodic dips, which experts describe as exceptionally strong. In view of this, it seems reasonable to conclude that Oumuamua resembles an oversized cigar in shape. But when it comes to its exact dimensions, experts can only speculate. These depend on a number of parameters that have not yet been conclusively clarified. And so it is that the object could be only 100 or even 800 m long. And as already mentioned, researchers were unable to detect any dust in the vicinity of the object. This led to the exciting speculation that Oumuamua could be made almost entirely of metal. But that's not all. Some considered it likely that the object had no natural origin at all, but was instead the work of an extraterrestrial civilization. The spaceship theory. If you think this theory originated in some semi-serious forum, you're barking up the wrong tree. In fact, we owe this approach to none other than Avi Loeb, an Israeli-American astrophysicist working at the renowned Harvard University. Together with his colleague Shmuel Bialy, Loeb came to the conclusion that Oumuamua has all the characteristics that would be expected of an artificial spacecraft. More specifically, the mysterious deviation from its trajectory and the lack of dust formation could best be explained by the properties of an extremely thin solar sail. This in turn is an artificial structure propelled by the radiation pressure of the Sun or another star. And while this idea is still in its conceptual infancy in our earthly reality, according to Lowe, it is possible that it has been realized by an extraterrestrial civilization and taken to a whole new level. And since the solar sail, which is estimated to be between 0.3 and 0.9 mm thin, has a very large surface area, it could not be pushed off its prescribed route by the radiation pressure of the Sun during its journey. But what does the rest of the scientific community have to say about this confident assertion? Well, basically the majority of scientists point out that Oumuamua's properties can also be explained by natural means. Among other things, there is speculation that the interstellar visitor is a fragment of a Pluto-like exoplanet consisting of frozen nitrogen. However, as the outer layers melted during its journey through space, it took on a flat cigar-like shape over time. And yet, the series of investigations carried out at the Green Bank Observatory in West Virginia in December 2017 shows that the spaceship theory was by no means dismissed as far-fetched from the outset. At that time, the radio telescope scanned Oumuamua for signal that could possibly be of artificial origin. For observation blocks, and 2 weeks later, however, came the big disappointment. No evidence of artificially generated signals could be found. Has the mystery finally been solved? Where extraterrestrial propulsion technologies were becoming increasingly unlikely, other explanations had to be found. Ultimately, however, it took until March 2023 before the redeeming news was announced that astronomers had finally solved the mystery of Oumuamua. And even if the solution doesn't really have much to do with solar sails and extraterrestrial intelligence, there is still some alien hope left for alternative thinkers. At the end of the day, these are purely theoretical models and considerations that provide a plausible explanation, but have not been directly proven by Oumuamua. Despite the lack of dust comas and mysterious accelerations, Darryl Seligman and Jennifer Bugner have managed to reconcile the strange circumstances with a coherent theory. According to their theory, the long-awaited answer to the Oumuamua question is hydrogen propulsion. The scientists arrived at this conclusion after evaluating a series of laboratory experiments conducted between the 1970s and 90s. In detail, the test series showed that water ice can disintegrate into molecular hydrogen under the influence of intense cosmic radiation, and a celestial body moving through the interstellar medium is literally cooked by this radiation. In view of this, it seems reasonable to conclude that Oumuamua also formed hydrogen. The problem here, however, is that the hydrogen should not have been able to escape into space immediately. To explain the speed boost after Oumuamua's orbit around the Sun, Seligman and Bugner also had an explanation for this: the hydrogen initially remained trapped in the pores of the ice. Calculations showed that this is anything but unlikely, and that most of the hydrogen formed in ice under interstellar conditions remains trapped in the water matrix. This only changes when the icy cage warms up to temperatures between -258 and -33 degrees Celsius. However, as long as this temperature limit is not exceeded, the water ice remains amorphous. It only crystallizes when heated to the appropriate temperature. And as Oumuamua entered the solar system, the Sun's rays heated its outer crust, causing the water ice to change its structure. The pores that opened in the ice then allowed the highly volatile hydrogen gas to escape. This also explains why the outgassing was invisible to the researchers. The molecular hydrogen could not be identified at all by spectroscopic analysis. Visually, it therefore appeared that Oumuamua had neither a characteristic tail nor a coma. In contrast to the normal outgassing of comets, the escape of hydrogen would not produce any significant dust formation. And even if the ice matrix did contain dust, it was most likely not torn out during outgassing. The crucial question now is whether this special form of outgassing is also capable of explaining the unexpected speed boost of the interstellar visitor. And the answer is yes, provided that the celestial body is also relatively compact. In the case of an object several kilometers in size, outgassing would probably have no significant influence on flight behavior. However, if Oumuamua is only 100 m long and 20 m thick, outgassing could have generated enough thrust to pave the way for the observed acceleration. And if you generate enough clicks, you can even pave the way for a new subscription. Simply press the thumbs up and subscribe to never miss a new video from us again. We'll see you soon.